Hello, math fans. A student is asking me about this in the discussion board. It's an old exam question. Some other students have said, yes, please talk about this. So I'm going to recap a few things about translating things that have to do with distance and corresponding points. This is not really a major topic. It does naturally lead to some 3D surface names, and so it's something we had. I do want to make one comment. This is not meant to be negative. It's just a comment about how I write exams. I tend to always have a few questions that come directly from homework. And so I want to comment because I think sometimes when I read a discussion post, I don't get the full story because sometimes people will be like, I have no idea how to do such a question. And we have a couple questions, again, not meant to be negative, but we have two questions from the homework that are very similar. And so the point of that is to say, if you see a question and you flip back through the homework and you see that it was there, and you're like, oh man, I saw this on the test. I had no idea what it was, but I had already seen it a few times in the homework. That's like a good learning moment of how am I approaching the homework? Because you want to be able to leave each homework question with something like, if I saw this again, I would have an idea of how to start it. Now, there's so many things in my life that I've learned and forgotten, but we need to somehow collect this if you want to do on the test of, I saw this a week ago, I need to be able to recall it or have a plan of attack. And so mostly that's just a comment about how we approach homework, because it's really easy to get caught up in the idea of, because it's a lot of work and you have other stuff going on, caught up by finishing as quickly as possible, using lots of resources or getting help, and not internalizing like, how do I start? Okay, so that's a good point of that is just, but as you're studying, there's two things that are good to do. Old exams are great. Another good thing is to flip through homework and say, are there any questions I don't know how to start? And make a little list of those and then start categorizing, how do I start? And this is one of those. So one of those is, how do I start a question that asks me to translate something to do with distance? So the few times we've had this happen, not just in those two homework questions, but it really happened in the first week of the course. My first lecture, in fact, is when we talked about this, and I posted a video about my idea of corresponding points. Okay, so if somebody says they want you to describe an equation for a surface, step one is to label x, y, and z as a point on the surface. You really need something to talk about. So these are the points you're trying to describe. Step two is to translate. Now, if it has to do with distance, one of your best tools is this. This is the distance between 2 points. Rather than learn a bunch of different distance formulas, and there is like, if you search online, you can find the distance to the xy plane and the yz plane and the xz plane. You can find the distance to the x-axis and the y-axis and the z-axis. You could find a formula for the distance to a plane, and you would have a collection of like 10 formulas. You say, do I have to put all these on my note sheet? So what I'm trying to do is simplify that for you and say, no, you don't need to do that. But what you do need to do is find the corresponding point. So what do I mean by that? You need to figure out what goes here. And that just gets us thinking in 3D. That's the part of these questions I actually like. So this one says, we want the distance from our unknown point to 0, 0, 2 to be the same as the distance from our unknown points to a point on the xy plane. Now you should know, if you have a point on the xy plane, that this is 0. And there's an easy way to fill in the other two pieces. And so this is how fast these questions can be. I'll say a little bit more about this. So if I give you a point, 2, 3, 4, and I ask you to go straight down to the xy plane, you know that the third component is 0, but you also know more. You know that the other two components are the same. So that's this. These are the same. So I've learned to do these questions almost routinely as basically I go, what does it mean to be on the xy plane? Boom. I need the other two things to be the same. Done. And then I just use the distance formula. So there's a routine way that requires like no 3D visualization really at all. X squared, y squared, z minus 2 squared. On the other side, you have x minus x squared And this was the concept. So if you search back and watch my video on corresponding points, maybe that'll make more sense now. Ultimately, what happens is this is just 0, and this is 0, and this is z squared. And then when I take the square root of that, it's just z, and that's not surprising. I already knew this was going to be 4, but I'm glad that the method gave me the same thing. So when all is said and done, I have the square root of x squared plus y squared plus z minus 2 squared is the square root of z squared, which you could also write as the absolute value of z. But since we're trying to name it, we're going to square both sides and try to identify what it is. So let's talk about that really quick. That's a separate issue, the identification, but usually the question is about that first part. So my hope is, based off that discussion, that you can now get here very quickly. Right? Almost immediately you can write this equation. The distance from xyz to 0, 0, 2. The distance from xyz to xy0. At this moment, I don't know the name of that, so I'm going to see if I can simplify. There's too many things going on. So I'm going to simplify and expand. I can subtract z squared. That's important because if there's all 3 squareds are there, it has a certain name. At this moment, we're done. Why are we done? Because we have a name for this. Now, I talked in class about how I do these, and I don't look in any sort of standard form. I just look at traces. So what I mean by that is, so this is now shifting gears to naming. But if you replace x with a constant, that means you have a parabola. How do I know that so quickly? Well, because you're going to have y squared and z to the first power. That's a parabola. It doesn't matter where it's located. If that's all you have left, it's a parabola. If y is equal to k, and you're only looking, and if it helps, I could write it over here. I need to give myself some more space. Sort of recap how we did this. Okay, if x is a constant, I'll just put a box where x was. You should see that I have 2 variables, one is squared and one is not. If y is a constant, you should see I have 2 variables, one is squared, one is not. The moment 2 of the traces are parabolas, we know the name. The name is paraboloid. So 2 of the traces, 2 different directions are parabolas. The name is paraboloid. That's where that comes from. That oid is a 3D parabola. Okay, the other trace, what do we get? We get x squared plus y squared minus some constant plus 4 equals 0. That's if z is a constant. Now, if both are squared and there's a plus between them, it's a circle. Now, there's always a subtlety of the other numbers have to match up to make it a positive on the other side, but we know for these that whatever the third trace is the adjective. Circular paraboloid. That's a reminder of how we name these things. But I imagine the question was about this translation. So since I already have them up, let's look at those 2 homework questions. Find the equation for the surface of all points that are equidistant from this point to this plane. Same idea. So I'm going to write distance, x plus 2, y minus 0, z squared. So that's the distance to the point. I need that to be equal to the distance to the plane x equals 2. So I'm going to write x squared plus y squared plus z. And we're going to use the corresponding point method. That's I have this point, and I need the corresponding point where x is 2. If you walk straight over to the plane where x is 2, I remember students asking about this back when we had this homework question. What can I say about that point? Well, I can tell you x is 2, and the other 2 points are going to be the same. So this is going to be y, and this is going to be z. You start to see how quickly this can be done. So this is going to be minus 2, minus y, minus z, and we have it. Now, if it's not a vertical or horizontal plane, yes, more work will be involved. I know I'm not giving the most general approach, But these questions that are just asking you to name are asking you about, it's leading to a shape we quickly know. Okay, now I'm going to square both sides, x plus 2. In fact, I think this question is essentially identical to what we just did, but this is harder than the one we did because it was x equals 2. Same thing, you're going to expand each side, you're going to subtract, and I think it's going to be a circular paraboloid again. So this is a harder version, this homework question, than this one, in my opinion. All right, what about this other one from the homework? Find an equation of the surface consisting of all points such that the distance to the x-axis is 4 times the distance to the yz plane. All right, we have a strategy. I'm going to find the corresponding points. I want the distance from x, y, z, these unknown points I'm trying to describe, to be 4 times the distance from x, y, z. Okay, so what is the first thing? I want this to be the distance to the x-axis. So what does it mean to be on the x-axis? Think about it for a moment. If you're on the x-axis, both of these are 0. And if you have the corresponding point that's closest to whatever point you have, this is x. Okay, if you're on the yz plane. Well, if you're on the yz plane, what can you say about that? X is 0, and if it's the corresponding point, these are the same. Done. It's that fast to think through it. When we're all done, this first one's going to be the square root of y squared plus z squared. Second one is going to be 4 times the square root of x squared, which is the absolute value of x, or you can leave like this. You square both sides, y squared plus z squared equals 4. In this case, all 3 things are squared, so it's not a paraboloid. If you play the traces game, this is one of those ones where when x is a constant, you get a circle. When the other 2 are constants, you get a hyperbola. This is a circular hyperboloid, but we don't call it that. There are 3 different flavors. This is the flavor where when you replace one of the x with 0 in this case, you get a circle of radius 0. And this is the cone, the circular cone. So there you go. Hope that gives a recap of those ideas. This is a smaller piece. This shouldn't be a major part of our studying, but it was more about our understanding of how to work in 3D. Hope that helps.